Hello. The following example is example 5 in section 1.5. If a projectile is launched vertically upward from the ground with an initial velocity of 100 feet per second, neglecting air resistance, its height s in feet above the ground t seconds after projection is given by the equation s equals negative 16 t squared plus 100 t. After how many seconds will it be 50 feet above the ground? Now the height is s, and it wants to know when is the height going to be 50 feet. Notice I don't need to define any variables here because everything is already defined for me. All I need to do is set s here, 50, equal to negative 16t squared plus 100t. So I get 50 is equal to negative 16t squared plus 100t. This is a quadratic equation. I'm going to solve this by adding 16t squared and subtracting 100t from both sides. Some people find this confusing. The reason I'm doing that is because I like the number in front of t squared to be positive. So that gives me positive 16t squared minus 100t plus 50 is equal to 0. Now look at the equation again. 16t squared minus 100t plus 50 is equal to 0. 16, 100, and 50 all share a common factor. What is it? Well, I'm not entirely positive, but I know 2 is in common, so I'm going to divide everything by 2. That gives me 8t squared minus 50t plus 25 is equal to 0. 8 and 50 share no common factor, and 8 and 25 share no common factor. Therefore, there is no other common factor between all three of these terms. What I need to do now is I need to solve this. I'm going to solve this using the quadratic formula. A is 8, B is negative 50, C is 25. So that gives me B squared minus 4ac is equal to, well, it's negative 50 squared, which is 2500 or 2500, minus 4 times 8 times 25. 4 times 25 is 100 times 8 is 800. So that's 1700. Notice because this is greater than 0, I'm going to get 2 real solutions. That's good. Using the quadratic formula, t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative b is positive 50. Plus or minus the square root of b squared minus 4ac, which is 1700, all divided by 2 times a, which is 8, so that's 2 times 6, so that's 2 times 8, which is 16. So that gives me 50 plus or minus the square root of 1700. Well, 1700 is 100 times 17, so the square root of 100 is 10. The square root of 17 stays as the square root of 17, all divided by 16. What's in common between those? Well, 50, 10, and 16 have a common factor of 2. So it gives me 25 there, 5 there, and 8 there. So that's 25 plus or minus 5 square root of 17 all over 8. Now this is the exact solutions. I'm going to go ahead and round this just so you can see what the actual decimal approximations are. So that gives me 25 minus 5 square root of 17 all over 8, and 25 plus 5 square root of 17 all over 8. So the negative gives me the approximation of 0.55. The positive gives me the approximation 5.70. I'm just doing it to the nearest hundredth of a second. Now, this makes sense because if you're launching something, the height can look like this. This is the time t, this is the height s. It's going to start at the origin, and as it's going up, it's going to keep going up until it reaches zero velocity, and then it's going to start coming back down. What it's wanting to know is, when does this cross at 50 feet? Notice that it's going to cross that at two different places. That's good because we got two real solutions. Notice if we had gotten non-real solutions, the height will never reach that height, or if we got a single solution, that's the maximum height you would ever get. So, the height will be 50 feet after 0.55 and 5.70 seconds.